Pandya, lecturer at Kalyan Polytechnic, Jamnagar. I am preparing this lecture to share this with GTU. In today's lecture, we will be covering topics from subject mobile computing and application development, which is being taught in Diploma Engineering Semester 6 in Computer Science and Engineering Department. The unit we will be covering is Unit 3. In this unit, we will be discussing topics which are on the screen right now. Basically, in this unit, we will be diving deep into the Android developing and will also learn basic building blocks of the technology. Before we start developing applications, we must know hardware design consideration, which is in general term means that Android devices have some limitations in terms of hardware, and a developer must keep them in mind whenever developing any application for Android devices. Android devices have limited memory, and therefore the application must respect the memory limit when performing any task given by the user. A developer should also know that such devices have a limited amount of battery, and any battery hungry operations or any lengthy operations should not be performed, or they should complete in a finite duration so that battery does not wear out rapidly. In addition to this, Android devices also have slow processors, lower resolution screens, slow data transfer speeds. Therefore, a developer must not use high resolution graphics. If such graphics are used, then it will increase the amount of data transfer on the network along with processing on the on a slower processor. If an application does not follow such standards, then the application is not user friendly and will reduce the number of users. On the contrary, design demands describes the criteria for how an application should be. It should not use a large amount of data on the network. UI should be properly visible and consistent on all the devices and all the screen sizes. It should also do not use high amount of processing and should be responsive so that user does not feel the application is not working. If any lengthy operations are being performed, then such operations should complete rapidly and securely. Now, coming to the main parts of Android development. In Android, screens can be considered as an activity, and an activity is a UI and presentation layer for our application. Activities can act as a host to fragments and views, ultimately displaying on the screen. In comparison, activities can be understood as a web page or forms in software, desktop related softwares. Like human, activity has a life cycle which indicates what is the state of our designed activity. These states are active or running, paused, stopped, inactive, or destroyed. Consider we are loading our application on the mobile and the application is started. Then this state is known as a running or active state. If the application is no longer on the screen or a user is no longer in the application, then this state is known as paused. If the application it is not being used for a long period of time, then system considered such application in a stopped state and can be abruptly closed by the system if more resources are needed in the current running process. onCreate method is used It is called when an activity is created. When a user opens the application, then some activities is created. You have to implement this method in every activity because inside this method all the necessary components of your activity will be initialized. Here the initialization of your application UI is done. Another method is onStart. This method is called when an activity becomes visible to the user. When all the initialization is done by the onCreate method, then this method is called. OnResume, which is our third method, it is called just before the user starts interacting with the application. Most of the core functionalities of the applications are implemented in this method. Another method is onPause. It is called when the activity is paused. For example, it is mostly called when you press the back or home button of your Android device. It is an indicate that the user is leaving the activity and starting some another activity or application. Another method is onStop. It is called when the activity is no longer visible to the user. If you are starting a new activity or some existing activity is entered into onResume state, then the current activity will not be visible to the user and is stopped. Next method is onRestart. It is called when the activity is in the stopped state is also about to start again. By doing so, the state of the activity from the time it was stopped will be restored. Last method in our life cycle for activity is onDestroyed. It is called when the activity is totally destroyed. When you clear the application stack, then onDestroy method will be called and all the states of the activity will be destroyed. Every project in Android include a manifest file, which is android manifest.xml stored at the root of Android project hierarchy. The manifest file is an important part of our application because it defines the structure and metadata of our application, its components and its requirements. This file includes nodes for each activity's services, content providers, broadcast receivers that makes the application, and using intent filters permissions determines how they coordinate with each other and other applications. Some of the manifest subnode tags are mainly used are as on the screen. To begin with, manifest tag. This is the root manifest tag with a package attribute set to the project's package. It should also include an Android attribute that will supply several system attributes within the file. We use version code attribute to define the current application version in the form of an integer number that increments itself with the iteration of the version due to updation. Also, version name attribute is used to specify a public version that will be displayed to the users. Next important tag is uses SDK. It is used to define minimum and maximum SDK version that must be available on a device so that our application functions properly, and target SDK for which it has been designed using a combination of minimum SDK version, max SDK version, and a target SDK version respectively. Next important tag is application. A manifest can only contain one application node. It uses attributes to specify the metadata for your application, such as title, icon, theme, etc. The application node also acts as a container for the activity, service, content provider, broadcast receivers, etc. that specifies the application components. Next and major part of our manifest file is activity tag that declares an activity that implements part of the application's visual user interface or UI. All activities must be represented by activity tag element in the manifest file, and any undeclared activities will not be seen by the system and will be never able to run the particular activity. Next one is intent filter. This specifies the type of intents that an activity, service, or a broadcast receiver can respond to. An intent filter declares the capabilities of its parent component, what an activity or service can do, and what types of broadcast receiver it can handle. The basic building block for user interface is view objects, which is created from the view class. The view class is a subclass of view and provides an invisible container that holds other views or other view groups and defines their layout properties. A layout can be nested, letting you create more complex UIs using a combination of layouts. Layouts are nothing but the combination of view groups. Before we dive deeper into each layout, we have some common attributes for view and view groups. To begin with, ID, or I should say Android :ID, is used to assign a textual name for the view in the application. Height and width is used to define a dimension for the view. Background is used to give background to a view. Visibility defines if the view or a view group is visible to the user or not. I will explain about margin and padding in the later parts of this lecture. First of all, linear layout is our first view group or a layout. Linear layout is a view group that aligns all children in either vertically or horizontally. There are so many attributes associated with linear layout, but here I will be covering some important ones in this lecture. Orientation. This specifies the direction of arrangement, and you will use horizontal for a row and vertical for a column. By default, the orientation value is set to horizontal. Another attribute is divider. This is a drawable to use as a vertical divider between views. Gravity specifies how an object should position its content on both x and y axis. Next, and probably the most popular layout in the Android community is relative layout. Relative layout enables you to specify how child views are positioned in relation to each other. Let me rephrase that. Relative layout specifies how child views are positioned in relation to each other. The position of each view can be specified as a relation to sibling elements or in relation to the parent. There are many attributes in relative layout which you can see on the screen, but for now we will not be covering this, but I will demonstrate them all in our next practical session. Next layout is grid view or grid layout. Grid view shows items in two-dimensional scrolling grid, either in rows or columns, and the grid items are not necessarily predefined, but they can also be automatically inserted to the layout. This layout can be used to create complex layout without resorting to the often complex nesting required to construct such complex design using relative layout and linear layout as we discussed them before. Because grid layout is made up of row and column, we can define maximum number of rows and column using row count and column count. Absolute layout lets you specify exact location of its children elements. Absolute layouts are less flexible and harder to maintain than other types of layout. Layout X is used to set horizontal position and layout Y is used to set vertical position of the view in the layout. Intents are the messaging body using which we can communicate between all the Android components. Intent also carries the information to pass between the components. For instance, we can use intents to pass some message between some activities or in between some other Android components. There are two types of intent. The implicit intent is used to specify some task and all the application that is capable of doing that task can perform this task. For instance, while using an application, you can set an implicit intent that you want photos, and the capable application will open and provide you with the required photos, just like a gallery application. The explicit intent is used to open another activity from a particular activity within the same application, like opening setting screen in your application. Now we will be discussing UI components for the Android activities. We have completed major view groups or layout in the Android. Our first view is Textview. Textview is a user interface control that is used to set and display the text to the user based on our requirements. The Textview control will act as label control and won't allow users to edit text. There are a number of attributes associated with Textview. We will dive deeper into each in the next lecture. For now, I will just explain few. For example, text is used to specify the text which we want users to see. Font family is used to specify what font type you want to use for defined text. Text all caps is used to display text content in capital letters. Next control is EditText. This is a user interface control which is used to allow the user to enter or modify the text while using EditText control. In our Android applications, we need to specify the type of the text field can accept. For that purpose, we use input type attribute. EditText control is an extended version of Textview control with additional features, and it allows users to enter input values. Next control is button. This control is used to perform an action whenever the user clicks or tap on the control. Generally, buttons in Android will contain a text or an icon or both and performs an action when the user touches it. One can use onClick attribute to assign an action for the button. Next control is ToggleButton. ToggleButton is a control that is used to display on or off states as a button with a light indicator. The toggle button is useful for the users to change the settings between two states, either on or off. State of the buttons can be predefined by checked attribute, and label for each state can be assigned by text on and text off attributes. Margins make up the vertical and horizontal areas between elements. If elements have no margin around them, then they will bump right up against each other. In other words, the spaces outside of or between elements is what comprises the margin area. The padding of an element is an horizontal and vertical space that's set around the content area of targeted element. So padding is on the inside of the box, not the outside. Thank you.